Dear students of class 10, welcome to you all in mathematics class. Uh, this class is a second part video of trigonometry classes. I hope that you all you all have participated in the part 1 video. In this video, I am going to discuss about uh, pattern-wise sample questions, and today this lecture will consist of type 1 creative questions. In type 1 creative question, you may be asked to derive some expression from given expression. Uh, there will some expression given, and there will be some expressions you have to derive from the given expressions. Or you might be prove some trigonometric identities. So it may be like this, prove that or show that, like this. There will be some identity, or in given condition you have to derive some expression or identity. So for these type of questions you will have to you must need some prerequisite, like uh, you have to be skilled over some special technique, like uh, you have to have control over algebraic formula and skill of algebraic calculation. If you cannot if you cannot um, do calculation, algebraic calculation, or if you cannot remember algebraic formula, then it will be very hard for you to solve this kind of questions. And you have to be skilled uh, on basic trigonometric identities, and skilled of applying correct formula at the correct place. So it will need it will need some practice for this kind of skill, for developing this kind of skills. Uh, if you solve the exercise problems, you can generate this kind of skills, and you have some insight of consequence. Like there will be some stage at where you may use two or three formula in the expression. There will be some expression coming up, and it will be you may think that you suppose you are doing some you are solving some problem, and you will have some stage of solving where you can apply three or four formula, but which formula is the efficient formula to apply there, uh, you have to find it out. And how to find this out, you have to develop some insight of consequence, and that is, what will be the next line if I apply this formula, and what is our target, what is to prove, or what is to find out. And for this goal of the math, or of the problem, for the goal of the problem, which formula is the correct. So you have to develop some insight of consequence. So how to fulfill this prerequisite? Firstly, forget all the creative questions. Simply uh, solve the problems given in your textbook as exercises, and some solve some individual problems based on trigonometry, in higher math trigonometry. And by solving them you will develop this kind of skills which will help you to solve the creative questions. Now we will take a question here, like question 1. In question 1, it is given that tan a plus sin a equal to m, and tan a minus sin a equal to n. And it is told to prove that tan square a minus sin square a equal to tan square a sin square a. Show that m square minus n square equal to 4 root over mn, and prove that sec a equal to root over mn into cosec square a. I know many of you have already solved this kind of problem, or you were very familiar to this problem, because this is a problem which is stereotype problem which is very common in S.S.C exam. Basically, this second problem is very common in S.S.C exam. So I hope that you all have solved this problem. But I am going to discuss about this problem because I want to assure you that how to develop the insight of consequence, and how to develop how, which formula is to used, and what should be done uh, stage by stage or line by line. You have to grow this kind of skill, and many of you may memorize, I have to do this and then it will be solved. But I don't want to depend on that type of skill, that is you memorize the steps and then you solve this. But I want to show you that uh, you can watching the problem and watching the statements given, or watching the statement we have to prove, you can develop your sense that by which you can solve the problems. And this is very essential, because in SS exam which math will be there you don't know, and also I don't know which math will be there. So if you want to memorize all the problems, this is not a solution. So what we will do is uh, we will ask ourselves why I am uh, doing this particular technique, or applying this particular technique, why I am writing this, why I am using this type of formula. So we have to ask ourselves, and we have to know that very clearly. I think this will take you to the goal. So firstly, we will prove that tan square a minus sin square a equal to tan square a into sin square a. So look at this expression. We have tan square a minus sin square a. We have angle A here, and we have angle A in the stem. So sometimes we don't need to use the stem. We just need to uh, sometimes we don't need to use the stem for answering the first problem of our creative question pattern. So in this question I have to prove that tan square a minus sin square a is equal to tan square a into sin square a. So we don't need to go to the stem here, because there is no m or n in the question, in the proof. So what we should do, we have to go either left side from right side, or we have to go right side from left side, because we have to prove that left side is equal to right side. So look at left side. At left side we have tan square a minus sin square a. So this is more like an algebraic formula, a square minus b square. So we will start from here, tan square a minus sin square a. Now this is tan square and sin square. We have to we have to go change this. We have to apply some formula, apply some calculation, and then we have to prove that the right side will be tan square a into sin square a. So we have to go to multiplicative form. Now if we could take common any of this item, either sin square a or tan square a, from this expression, then it will be uh, solved. So we have broken down tan square a by sin square a by cos square a, because we know that tan a equal to sin a by cos a, and then we can take sin square a as a common factor, because actually look at the right side here, two things are factorized, tan square a into sin square a. So sin square a is a factor here and tan square a is another factor here. So to build up factor we have to take something common, and to take something common as common factor we will have to get some sin square a or some tan square a from here or from here, and in the both of the terms either we have to generate a sin square here or we have to generate a tan square here, because we need to take tan square as common or sin square as common. We know that tan square equal to sin square a by cos square a. So if we write this, we can take sin square a as a common factor. This is the secret of applying this formula. Or we could apply sec square formula here or cos square formula here. But how do we know that we have to apply sin square a by cos square a? Because we want to take sin square a as a common factor. So as a common factor sin square a, we have taken sin square a here, and we have got 1 by cos square a minus 1. Now 1 by cos square a minus 1, you can write it like this, equal to sin square a into sec square a minus 1 equal to sin square a into tan square a. You can go to like this, or you can go like this. You can take cos square a as the LCM, and you will get 1 minus cos square a over the denominator. As the numerator you will get 1 minus cos square a after subtracting the 1 from 1 by cos square a. Then 1 minus cos square a equal to sin square a, and now you can get it easily, sin square a by cos square a is equal to tan square a. So this is the technique to derive, or technique of thinking what to do now. Uh, take any of this common. If you take tan square a as common factor, what would be there? So I will write it here. If we take tan square a as common, tan square a, I want to take common. If you take something common, then you have to divide both terms with the common factor. You will get 1 minus sin square a by tan square a. You will get this. Now sin square a by tan square a, and what to do now? We have got sin square a by tan square a. We can write it tan square a into 1 minus sin square a into cot square a. We can write it like this because sin square a by tan square a, and 1 by tan square a can be written as sin square a cot square a. Now you can write this tan square a 1 minus sine square A into cos square A by sine square A. You can write it like this. Now you can see this sine square A and this sine square A will be cancelled. Therefore you can write equal to tan square A into 1 minus cos square A. And then you can write it like this, equal to tan square A into 1 minus cos square A is equal to sec square A. So this is another way of proving this. So if you are conscious about what to do from to get right side from the left side, or what to do to get from given expression to required expression, then it is very easy. Whichever way you take, you will go to the destination. And you can see that I have done this. I have taken this expression. I have converted this expression uh, to sine square A into tan square A in three ways. And the first way was like this vertically, and second way is like here, like this, and third way is like this. So whichever way you take, you can answer the question. Just go logically and sensibly, which will take you to the goal in a logical or in a efficient method. Now we want to solve the second question. Show that m square minus n square equal to 4 root over mn. So here we have m and n as given in the stem. So m and n are given, and at the left side we have got m square minus n square. So we have nothing to do but putting the value of m square minus n square here. If you put the value of m square minus n square here, you will get tan a plus sin a whole square minus tan a minus sin a whole square. So we are given that tan a plus sin a equal to m, you put it in equation 1, tan a minus sin a equal to n, put it in equation 2, and we have to prove that m square minus n square equal to 4 root over mn. Writing this before starting the math is a good practice, because you don't have to go to the question uh, frequently to see what to do now, what to do now. This type of technique will help you to solve the question. And also, whenever you will write this by your pen in the paper, then it will make more sense to you. At least I can say that it helped me. So if you write these given things in a line and to prove things in another line, it will help you to solve the question. It is a good practice. So at the left side we have m square minus n square, m square minus n square, and we putting the value of m and n from 1 and 2 using equation 1 and 2. We have tan a plus sin a whole square minus tan a minus sin a whole square, and then uh, we can say that a plus b whole square minus a minus b whole square. This is the formula of 4ab formula. Therefore you can write it immediately like this: 4 tan a into sin a, or you can use the formula a plus b into a minus b. You will get this by applying this. Then 4 tan a tan sin a. Now we have written it like this: 4 root over tan square a into sin square a. Why we have written it? Because look at the right side, we have to go for root over something. So we have already got 4. Now we need to introduce a root over, then an expression. So after 4 we have got tan a and sin a. So if we want introduce a root over sign, we have root over, then to cancel the root or to balance the root, we have to uh, give a square here. all I all things I am doing here to go to our destination 4 root over mn. Now we have got 4 and root over. Now we want to go to m into n. We have got tan square a into sin square a. It is not m into n because m equal to tan a plus sin a and tan a minus sin a. So we have to go to tan a plus a, tan square a into sin square a. We have convert this expression tan square a into sin square a to tan a plus a into sin tan a plus sin a into tan a minus sin a. We have to convert this like this, m into n. So how to do this? Now we will take the opposite technique we have used in our solution of a, which is we need to we need to here we have got two terms are multiplied, tan square a into sin square a. Now we need to introduce some plus or minus. We have to make it divide the expression in two terms expression. And in two terms expression you have to do like tan square a, you can write it 1 tan square a equal to sec square a minus 1, or you can write it sin square a, you can write sin square a is 1 minus cos square a. So we are very certain about it, sin square a is equal to 1 minus cos square a. So we have kept the tan square a same. We just converted the sin square a into 1 minus cos square a. Why? We want this minus or plus. We want to divide it into two terms. Here we have one term, we need two terms. Therefore we have introduced this formula here, applied this formula here. Now tan square a, multiply them. Multiplying tan square a is with 1, you get tan square a. Multiplying cos square a and tan square a, you will get tan square a into cos square a. Now we need to vanish this cos square a. We need to eliminate this cos square a. To eliminate this, we can break down tan square a by applying sin square a by cos square a. And sin square a by cos square a, after applying sin square a by cos square a, it will cancel cos square a and cos square a, and you will get tan square a into, you will get like this, cos square a and cos square a are cancelled, cos square a cancelled, and this cos square a also cancelled. You will get tan square a minus sin square a. You will get only tan square a into sin square a. So whenever you get tan square a minus sin square a, you will you are able to apply a plus b into a minus b formula with tan a plus sin a into tan a minus sin a here. Now we don't need it here. You can write 4 into m for tan a plus sin a and n for tan a minus sin a, and which is equal to right hand side. So I am sure that you are discovering this math more analytically when I am giving this description. And now we are going to solve question number C. Question number C is prove that sec a equal to root over mn into cosec square a. Now we are going to solve this. We are given that sec a equal to root over mn into cosec square a. So at the left side we have sec a, and at the right side we have root over mn into cosec square. So at the left side we have taken sec a. Now we want to go to the right side. We want to convert the sec a into root over mn into cosec square a. So you need a root over first. You need this root over. So to introduce this root over, you will write root over sec square. Now you have got this root over. Now you need a cosec square a. So you introduce a cosec square a here. You have written a cosec square a as here, and you have to divide this sec square a by cosec power 4a. Because this root and this power 4 will be cancelled, and you will get cosec square a at the denominator, and this cosec square a and this cosec square a will be removed, and it will balance to root over sec square a. So to balance the whole thing, you have to introduce a cosec square a and divide uh, sec square a by cosec power 4a, because it is beneath the root. Now as you can see, sec square a and cosec square a, you have got this root over and you have got the cosec square a here. Now all you have to do is prove that this sec square a into cosec power 4 divided by cosec power 4a is equal to root over m into n. So to do this, cosec power 4, we will divide this cosec power 4 into two parts. We will need to introduce mn, so uh, we have to convert this in sine and tan. Therefore for first stage we have taken sec square a to the denominator, and it will become cos square a, and we have taken cosec power 4a to the numerator, and it will become sine power 4a, because 1 by cosec power 4a equal to sine power 4a, and 1 by sec square a equal to cos square a. We have flipped this denominator. If you take sec square a at the denominator, it will become cos square a, and if you pull the cosec power 4a to the numerator, it will become sine power 4a. Now you have got this. Now sine power 4a. So we will break it down like this: sine square a into sine square a by cos square a, because we need to bring tan square a, and sine square a into sine square a by cos square a, and this cosec square a will remain the same. Now you can write it sine square a into tan square a, and this term sine square a by cos square a is equal to tan square a. Now you can see sine square a into tan square a, and from it uh, likely the method we have used in previous math, question 1b, you can derive that the term sin square a into tan square a is equal to tan a plus sin a into tan a minus sin a. So we have broken down this sin square a into tan a into 1 minus cos square a, and we have multiplied tan square a and cos square a here, and we have broken down tan square a in sin square a by cos square a here. We have kept the cosec square a same. uh, we have taken the cosec square a at the front of root over sine to uh, remove the confusion, to get away from the confusion. And here you have we have broken down tan square a into sin square a by cos square a, and this cos square a will be cancelled, and you will get tan square a minus sin square a, and then you will get tan a plus sin a, tan a minus sin a, and it is root over m into n. So you will get root over mn into cosec square a equal to the right side. This is the solution technique of question C, and you can see that I have designed this question in such a way that we have used the same technique for proving three different identities, or proving three different statements which are given. The same thing we have done to and fro. Sometimes we have gone in question 1 we have gone tan square a minus sin square a to sin square into tan square a, and in question uh, B and C uh, we have pull it reversely. We have done it in reversely, that is tan square into sin square equal to tan a plus sin a into tan a minus sin a. So this is all for today. We will discuss about another type 1 problem in our next class. Up to then, up to then I am suggesting you to open your book and find out some model questions and solve them by yourselves. And then if you get any problem there, uh, you can ask me in the comment box, and you can if you have any special question which you cannot solve by yourself, you can submit me in the comment box to solve the question for you. I will be very happy to solve the question for you and take another class on that type of problem. So up to next class, stay well, stay connected, and let me learn your progress and let me learn your confusions. uh, I will be more than happy to answer your questions and to remove your confusions. Thank you, and study very hard and get prepared for S.S.C exam very well.